So, welcome everyone. My name is Aaron Smith. I am the CEO of the Energy and Environmental Building Alliance, and I'm joined as always by Nancy Bakeman, our Executive Vice President. We're reaching out to you today from Minneapolis, where it's much cooler than it was over this past weekend. We were in the heat dome, which was terrible. There are some great technologies out there from our friends at Goodman Daikin. As I went to Europe this past summer, I took apart all the mechanical rooms and looked at the Altherma units that were across Europe. And I think I've been begging Jason Thorson for 3 years to bring this technology to the United States. So today we're going to hear about one condenser to rule them all, or three-in-one condenser solutions. This would be the Goodman Daikin Altherma product, which is fantastic. And we've got an incredible lineup. So many of you know Jason Thorson, who's in business development for national accounts for Goodman Daikin. Jason, great to see you. Kelly Hernsberger, who is a building science guru. I think Kelly and I are much like our houses are experimental labs for the latest and greatest in building science. Kelly is the Vice President of Advanced Product Marketing and Innovation. Kelly will be presenting us today. And then we have a very special privilege, Mr. Hong, who is the Vice President of CEO staff for Goodman Daikin, will also be presenting to us. We'll go through the technology. We're going to talk a little bit about what the future case looks like in some example installations in Europe. And then we'll talk about some test bed locations that are going on in the United States. Any in Canada right now, or just across the United States? I think most in the United States right now. So
Yeah, these are we have one kind of unofficial field trial in Canada and the
okay,
Mid-Atlantic. Yeah.
yeah, no, fantastic. So with that, Goodman Daikin, thank you so much for being here, and I'll turn it over to your team. And again, please put questions in the Q&A, and we'll answer those throughout today's presentation.
Perfect. Perfect. Thank you, Aaron. And that was a great intro. And with that, I'll turn it over to Mr. Hong and Mr. Hernsberger. It's an exciting message and opportunity in North America with this product for the applications, both new construction and retrofit. So with that, Kelly, I'll turn it over to you to get things started. Thanks, everybody, for attending. And we'll get our contact information out. Please don't be shy. Reach out. Contact myself. I'll sorry, messenger. Get with Mr. Hong, Mr. Hernsberger, and we'd love to work with you. So with that, Kelly, take it away.
All right. Thank you. So Mr. Hong, if you'd be kind enough to start presenting. Appreciate that. So what Mr. Hong and I are going to do is walk you through the technology, as Aaron said, and then bring you to a point where you can see some case studies and understand the application more clearly. And then we can make sure we haven't, if we haven't already done so, we'll try to address any questions after that. So what I'd like to do then is just introduce the Daikin Altherma 3 product line. Daikin has had this product line for well over 20 years now in the European theater, European market. And what we're essentially doing is taking that technology and localizing it to North America. We previously had this technology here until 2011 or 12 or so, but as you can imagine, the market was not quite ready for the push we've had lately on decarbonization. So that's kind of the idea there. And I often tell people, just like Aaron said, if you want to see what's happening here now, go to Europe and have them rewind the movie for a few years and start playing the movie back, and you'll see where we're at here based on the technology advancements in other regions. So quite simply, decarbonize, electrify heating, cooling, and domestic hot water with one heat pump system. We're going to talk about that, and I'll break that down in a little bit more detail. Next slide. So just to be really clear, the solution is a 3-in-1 solution. As I said, heating, cooling, and domestic hot water are all accomplished with one heat pump system. What we have is the same attributes that you know of from our other inverter systems, where we have not only focused on the comfort, but also the energy efficiency. Of course, high reliability, because we're all vertically integrated with our system, and then a high level of control. A really good range of applications, and more specifically, including low ambient conditions as well. So if you're in a northern build district, northern environment where you've got a lot of heating hours, this might be a really interesting solution for a new build product. And then, our signature product is really our compressor technology. That's what's essentially enabling this engine to operate the way it does. And we get really good seasonal efficiency. So you can think of this as the best of what you had always imagined a boiler being able to do, but now you're bringing in high efficiency electric operation, and then of course the cooling aspect is added on. No doubt you don't have to imagine we're replacing fossil fuels with this product. And then we see this as a more sustainable future look, where people are used to hydronics. They would establish their home with this technology. No more delivered fuels or propane, tank fills. This solves a lot of those issues. And then we use our R32 refrigerant in this system. In Europe today, they're using other refrigerants on their latest generation. They've just migrated from R32 over to propane, and in some cases CO2. So they're moving into that next wave of refrigerants, whereas we're just now adopting A2Ls in the States. Next slide, please. So I'll start to describe a little bit about the system now, and then I'll break down even further the elements, each individual element. The first question that we get a lot of, or the first comment I hear a lot of in the hydronics world for heating is, well, you got to give me 180 degrees. And that's what typically had been the norm when people thought about boilers and how baseboard or radiators were designed. And we definitely appreciate that comment, but we're also producing a system that is going to replace those with more efficiency, even at lower temperatures. So we're able to reach a phenomenal temperature output on a heat pump up to 160 degrees Fahrenheit, leaving water temperature. And we can do that as low as minus 28 C or minus 18 Fahrenheit. So that's a fantastic, it's a really strong heat pump system. It's designed for ultra cold climate environments. These systems are operating in Europe and Norway and Finland, and areas where heat pumps are adopted a lot more rapidly. They're utilizing these particular systems. So imagine those environments analogous to North America. That would be your Wisconsins, your Michigans, your up into Manitoba, into Canada, into the northern territories. That's really strong performance in cold conditions. Again, one solution will provide the heating, space cooling, and also serve the domestic hot water with a tank. And I'll show you more about how that works. And then we also see this as a high COP. We have outdoor reset, similar to what you'd see in a boiler, only it's a little bit more sophisticated because we can match the load line of the envelope or the occupied space with the performance of the unit and the weather conditions, and we can hit and strike an extreme balance, the most economical balance on water temperature. Next slide, please. A little bit on the mechanics on how things work, and I'll just demystify the system here up front. We do not do all of those things simultaneously. We do have advanced systems in VRV that are capable of serving, hot water, low temp, if you will, and then heating and cooling simultaneously. But in this particular system, there is a priority set at the setup of the system. And you can see here on the bottom, of course, we've got our outdoor unit. And you can see that at the top, there's a head unit, or what we call an indoor wall mount unit, or a hydro box. That's typically more of a manifolding system with the brains of the unit in the head of the system. And then, of course, we have a domestic hot water storage tank. And that is an indirect tank because there is a heat exchanger inside there with a loop. That's a closed loop. So the outdoor unit generates hot or cold water, chilled water. The three-way valve in the center there is directed to move the hot water to meet a heating space demand or a cooling space demand, and that goes to the left over here with the different fan coils, convectors, hydronic baseboard, radiator, hydronic air handler, or in-floor underfloor heating, and or it directs the priority for hot water to the domestic hot water tank if there's a call or a necessity to top off that tank. Or in the summertime, if you're in cooling mode, it would direct the chilled water to the appropriate air handlers or fan coils on the left-hand side. If you look from the bottom to the top on the hydronic distribution on the left-hand side, of course you can use hydronic baseboard if people really want to utilize that, or radiators, slim radiators. But the most exciting product lines here for a new build would be the floor standing heat pump convector. It's a very slim profile. I'll have pictures of that in a moment. It would replace the familiar radiator in a new build home, and it provides the comfort that you would have received from the radiator from before, but now it's utilizing a small micro fan coil. So you're getting very good heat and cool output, but you're only using a very small amount of energy. And that's why you can heat at 140 degrees through these convectors, just like the high wall, it's buddied to the right-hand side there. And they show the symbols of heating and cooling. So those are capable of heating and cooling. They do have a drain pan and a pump. So you would plumb to those appropriately, just like a typical fan coil. And that's where I would put my easy chair, somewhere close to that heating element, because it is producing very nice warm and toasty heat or nice chilled air. And then, of course, you're familiar with underfloor heating. And the hydronic air handler is a very familiar choice to replace the fossil fuel gas furnace. And it would also provide, accurate zonal heat as well. So that's kind of the system play, the architecture. Again, reminder, the heat exchanger, the plate heat exchanger producing the hot waters on the outdoor unit. There is no refrigerant flowing from the outdoor to the indoor. It's all encapsulated in the outdoor. So it is a package unit, for lack of better definition, and there's no refrigerant work required to install this system. So we'll talk later about the challenges of if it's a plumber installing this or a heating and cooling company, or that's something we'll have to address. But that's how the system works. And this, again, just as a reminder, I'm seeing some comments here. It is R32. So next slide,
Kelly,
please.
Kelly, can
Yeah.
you just mention if there would be any difference in this system layout from a retrofit versus a new build situation? Thank you so much.
Yeah, I would say as we first are launching this, we were thinking about the retrofit, replacing boilers, the fossil fuel districts. But from a new build, what I would think is so strong, compelling architecture would be to utilize these convectors or underfloor radiant heating
Mm,
and a hydronic air handler. I think I'd utilize those elements. I wouldn't worry myself with hydronic baseboard. It's a bit messy. You got furniture laying around, you got limitations on where you put stuff with windows. I think the other elements are the top four on the left-hand side are probably my choice for new construction.
mhm.
And the home in mid-Atlantic Canada, it's set up with underfloor heating predominantly through the house with a couple of spot areas that are being served with the either the high wall or the floor standing heat pump convector. So
Great. And
that's
I
how I
think when
would
we,
set that up. Yeah.
yeah, and I think when we get into the case studies, people will see that, here's an example of a retrofit situation. Here's an example of a new. So we'll get into that
Yeah,
more
we have that.
as the
Yeah.
questions come in. Thank you, Kelly.
Yeah. Okay. I'm gonna move along pretty rapidly now. Next slide, please. So just to kind of break those elements down a little bit, there's a communicating thermostat. And of course, it goes without saying, there's an app. So you've got the, water temperature of your tank on your phone. You could schedule your domestic hot water. There's multiple things you can do with that app. But then you can see there's different sizes, two unique sizes on the outdoor unit. And by the way, don't let those fool you. The 36,000 BTU and 43,000 BTU output units. There's definitely some sizing rules around this, but just to give you an idea, they're not you wouldn't BTUs are BTUs, right? At the end of the day, but you've got to think about this product as a room by room heating and cooling load design aspect instead of a block load. And then you'll also recognize that I know you guys know this, but a lot of people don't understand that boilers are significantly oversized in northern markets, sometimes by a factor of two or three. So it's interesting to see what these systems can do. One of the larger outdoors, the 43,000 BTU system, for instance, is serving 6 small apartments in Boston right now as a field trial, and Mr. Hong will show you that. There's only one indoor hydro box unit that we use for this system as we launch. And then, of course, the tank size depends on your loading of water usage, and that's always done, of course, in a particular calculation or method based on how many people, what is the water usage pattern. But this has a very strong recovery rate for water heating. And even if you were in heating or cooling mode for the space temp and you needed to come back over to domestic hot water, you could have a completely empty tank and fill that 50-gallon tank up in around 55 minutes. So with 130, 140 degree water. So it's a very strong recovery unit. It also has an option for a 3 kW electric booster heater. So if you needed strong or performance mode, high performance mode, or that last fourth person or holiday mode where there's 5 people taking showers, you could hit the electric boost heater and activate more hot water. Next slide, please. Now, a little bit about the air movement capability. We've got, as I said, these premier convectors. We call them convectors, just call them air handlers, but they're really slim, very sleek profile. Even the high wall unit is about half of the size of the cassette that you'd see in a mini split. Pretty low profile, easy to work with. We also have isolation valves, depending on how you plumb these things. You can run these all in parallel. And then, of course, you don't need to pump the water through the coil to get to the next unit if you're in one circuit. So one thing that's kind of unique is anyone that's been in the hydronics business knows that the sky's the limit. Your imagination, whatever you imagine a hydronic system can do, you can do it as long as you know how to plumb it, control it, and make sure you have the right water flow. So anyway, that's why we've designed these. The output varies from 3.5 to 7,000 BTUs on these convectors. And believe me, when you turn them on, especially in heating mode, you'd think that you were standing beside a radiator. It's that strong a heat. The hydronic air handler is right now a partnership with First Company. They have a wide variety of air handlers, but this particular air handler is both a combo heat and cool coil. So it was sized appropriately for heating and cooling. And then, of course, at the bottom, you can see there's an accoutrement of valves, isolation valves, and kits that we supply with the units, and you can get as filled pieces. Next slide, please. Okay, a little bit about sound. I mean, it's a hallmark feature for Daikin all around. I think people understand that, we have designed systems that are, their hallmark is, the sound profile is really low. So that outdoor unit was designed in mind from the Europeans to be able to put under the kitchen window or underneath the window at the master bedroom. It is super, super quiet. And it can also, just in standard mode, it can also be programmed to have ultra low sound mode or nighttime mode, if you will, if you're in some districts where there's a sound ordinance. But to be able to hit 35 dBA and have the output just only slightly reduced for capacity, that's a very strong unit that offers a lot of flexibility on where you put it. So super quiet unit designed for sound comfort as well. Next slide. And then just a couple of more slides here, and then we'll get to the field studies. But I just wanted to point out that, there's an outdoor unit. It's in Daikin fashion. It's very stylish. Really love the look of this unit. Pretty sleek. It's a Red Dot Award winner from Europe. It does have the epoxy coating, so anti-corrosion is built in on the heat exchanger right away. It is our 7 millimeter diameter tubing, so high performance as well. Standard 1-inch diameter water connection. So I think that's very straightforward. Of course, drain pan. We'll talk about that in a moment and more unique opportunity there. But then the heat exchanger, the brazed plate heat exchanger for the R32 to water heat exchange is located on the outdoor unit. And so that is the standard, along with the 4-way valve, of course, that's doing your switching for the heat pump. So let's go to the next slide. A little bit about the drain pan itself. And if you're in a northern climate, I mentioned before, these systems were designed uniquely even for northern climates. And so what we do on the drain pan is we pull off some hot gas from the refrigerant circuit, and we bypass that into the drain pan. So we run enough circuit to make sure that we clear that drain pan all the time. So consistently in heating, there's no necessary additional kits, electric penalties for the system. We're just stripping off a little bit of that hot gas bypass and then utilizing that to keep the drain pan clear. Next slide. So thinking about keeping things clear, we get a lot of questions about freeze protection and hey, you're pumping water from an outdoor unit into the indoor um, section, and wow, this thing's exposed to the elements, and so we not only the first thing is I need 180 degrees. The next question is, well, what do you do if the system loses power or it's exposed to the elements. Well, the first thing we teach people is how to properly insulate water pipes in a very short run that goes from the outdoor to the indoor. And then sometimes, there are some exposed portions of a basement that might not have good insulation. But in the case that we're talking about today, this is all new build construction. So when you imagine how you build a home with this system, you actually create a small little alcove or a place for the outdoor unit to be pretty close to the penetration you're going to bring the pipes into the basement or into the area where you're going to have the mechanical room. So very short run, insulate it well. And then in the event that you do lose power, we have antifreeze valves that trickle, we'll call it. They would trickle a little bit when we get close to freezing, 36, 38 degrees, they're typically set. And then they would prevent the pipes from freezing because you still have a little bit of water flow. In the event that that's not acceptable to a homeowner or your build practice, you can use glycol in this system. It's a closed loop system with a double wall protection against the domestic hot water. So you could run glycol. It does come with a little bit of a performance derate, but I think that's common. Most people understand that, even with boilers. So there's multiple options. We encourage people to design properly, just use common sense on the design practice, and likely you don't need to have a lot of extraordinary efforts, even in colder climates. Next slide, please. So a little bit about the indoor unit I mentioned before. It's a bit of more manifolding and a head unit with the controls. You can see there's a display. It might be hard to see in this slide. We call it the man-machine interface, or the MMI. Sounds Star Trek-ish, kind of, but yeah, MMI. And then there's some water, a magnetic water filter. Of course, the pump for the system is there. Of course, there's other things like flow sensors. There's an expansion valve or expansion vessel built in. Also, the backup heater. And what I didn't mention before is if there was a situation where the outdoor unit needed a maintenance call, or there's something that took the outdoor unit from play in the system, the backup heater is a 6 kW backup heater inside the head unit. And so it could serve the heating and the hot water space adequately until that outdoor unit can be serviced. It does not have to be wired in directly into its own breaker. It could be in a shared breaker with a car charger in your design build environment. So there's a lot of unique ways you can operate the system breaker-wise as well. Next slide. And then I think lastly, I'll just leave you with a little bit of an emphasis on performance before we go into the discussion on field trials. And what I love about the system, it's called Altherma 3HHT. That's high temp. The hydro is the first H, and then HT is high temp. But what we'd like to talk about here is that you can get the leaving water temperature at 160 degrees at -15 ambient with just the heat pump solution only. And then the heat pump plus the backup heater would get you down to the -18 Fahrenheit environment with a leaving water temperature of 160 degrees. That's strong performance. It's not only good for renovation to remove boilers, but it's just a really smart design if you want the comfort of the premium in-floor radiant heating, high performance COP system. And then on the right-hand side, you can see we've done some comparisons with the spec sheets that we can scrub today off the websites. And those are primarily units out of Europe, but I would just tell you that there are a variety of systems at play in North America, predominantly in Canada right now, and we've evaluated against those. The key characteristic I wanted to point out is, or emphasize, if you look at that top blue line where Daikin is at versus the competitors below, everyone seems to either stop or drop off dramatically with water temperature when you get to the extreme outdoor temperatures, the -20s, -25, -28 Celsius or -18 Fahrenheit. And we just have a very low sloped line where we're still performing at a very high water temperature output, even at those unbearably cold outdoor temperatures. So we've got a really strong heat pump that we're going to be bringing to the market. And the exciting part is that it's just even more efficient with outdoor reset functions or, what we call load space management, load line management. So really strong unit. Love the performance we're seeing so far. And I'm going to turn it over to Mr. Hong, and he's going to take us through some examples of what we're seeing already in North America.
Okay.
Thank you.
Thank you, Kelly.
Thanks, Kelly.
Thank you. Right. So now I would like to present some case studies in Europe and North America. Let me start with Europe first. Daikin Altherma history starts from Europe in 2003. This is the first field test in Norway. Their design temperature is -4 degrees Fahrenheit with high humidity and heavy snowfall. We installed Altherma with underfloor heating and fan coil units on their first floor, second floor, and bathroom. 21 years later, we contact the homeowner and receive this message. Still running well with my Altherma. Replaced the floor switch and a water pump a long time ago. Never had any big problems. Yes, maybe this is what you expect from Daikin Altherma. Let me introduce another case study in Belgium. We installed high temperature Altherma at one of the houses around 2,000 square feet in Belgium. Their design temperature is 7.6 degrees and heating load is 30.7 thousand BTU per hour. They have 4 units of radiators with 150-degree living water temperature, 3 units of convectors, and 6-gallon domestic hot water tank. You can see on outdoor unit radiators for heating on their first floor, convectors for heating and cooling on their second floor. On January 11th this year, their indoor room temperature indicates 71.6 degrees at 30.2 degree ambient temperature. Also, until now, their average COP is around 2.7. When we had market research, a lot of our customers were concerned about defrosting cycles on the heat pump system in winter. Let me show you a short video of the defrosting cycle on Altherma. Total duration is around 5 minutes at 30.2 degree ambient temperature, which does not impact your indoor room temperature. We also have heard from our customers concerns about a drop in heating or cooling performance when using domestic hot water or any cases of hot water shortage. Here is the feedback from the homeowner. First, in winter, the changeover from space heating to domestic hot water mode is now affecting the comfort in his room. The room temperature drops by less than 0.5 Celsius during domestic hot water mode. Second, in summer, when the cooling mode is interrupted for domestic hot water making, the room temperature could increase by 2 to 3 Celsius. Yes, this is noticeable when awake. So, light sleepers better program domestic hot water making during morning or daytime in summer. Third, domestic hot water comfort. For people living in this house, each taking one shower a day, a bath from time to time, showering time is 5 minutes to 20 minutes. Lack of hot water never happened. Now, let's imagine a house in Boston. Let's say their heating load is 40,000 BTU with 150 radiator and 5 design temperature. At a 5 design at a 5 ambient temperature with 150 living water temperature, Daikin Altherma provides 36,000 BTU with heat pump operation only, which is close to the heating load. When you consider 6 kilowatt megameter inside the indoor unit, the total capacity will be 56.5 thousand BTU. Energy simulation tells us that for 41,000 BTU house with 150 radiator in France, where design temperature is 5 degrees, most of the energy will be produced by heat pump only. And energy produced by the booster heater will be less than 0.1%. We will check this number from our field data in main state later in this presentation. Now, let's move to the case study in Germany. The value of our property has increased considerably thanks to the new heating system. We have upgraded our house and are saving just over 1,000 euro annually compared to the old oil heating system said by homeowner. Let me point out 3 points on Daikin Altherma. First, high temperature heat pump heats reliably even with existing radiators. They had been using an old boiler with radiators, so they need a high temperature heat pump. But there are very few suitable products, so they opted for Daikin high temperature Altherma. Second, low cost and CO2 emissions. Their annual oil boiler cost was around 2,500 euro with an annual oil consumption of 580 gallons. Now, their annual Altherma cost is around 1,400 euro. This means compared to heating oil, they are saving over 1,000 euro annually. Third, suitable for densely populated residential area. The outdoor unit of Altherma is particularly quiet at just 35 decibel at a distance of 10 feet. So they could install their outdoor unit in the garden at the rear of the house. Here is another case in Germany, replacing gas heating with high temperature Altherma. First, climate-friendly heating with heat pumps is also possible in old buildings. First, Oliver Kuhl, who is the operation manager of the contracting company in Germany, says that many of his clients are looking for alternatives to fossil fuels, but are unsure whether installing a heat pump in their existing buildings makes sense. His answer is very clear. Yes, it makes sense. Second, replacing their oil gas heating within 2 days. Within 2 days, contractors dismantled the homeowner's 14-year-old gas condensing boiler and installed Daikin Altherma. Third, whisper quiet operation thanks to special fan. The homeowners' neighboring houses are very close together, but you can't hear it at all. It's like a gentle breeze, said by homeowner. Also, the visually appealing outdoor unit now stands in the homeowner's front yard on the side of the house, and it makes Altherma blend harmoniously into the building's architect. I think this is really the most attractive unit currently on the market, said by homeowner. We also have another study case in France, but let me skip the details. Now, I'd like to present some demonstration projects in North America. So until now, we talk about high performance for cold climates and ultra low sound, and we believe this makes a major differentiation from our competitors. We are able to achieve these capabilities by leveraging our long history of heat pump development and core technologies like inverter compressor technology and refrigerant controls. Furthermore, these high performance and ultra silent sound level technologies are patented by Daikin, which means it is difficult to copy Daikin Altherma. That being said, we understand that we still need to verify performance in the North American market. So before presenting demonstration projects in North America, let me introduce briefly about Asaikawa Lab in Japan. We have model houses in Hokkaido, Japan. Hokkaido is the most northern part of Japan and is similar to Minneapolis in its latitude, and they have heavy snowfall also. We installed high temperature Altherma at one of the model houses. As you can see, our Japanese engineers have checked all the data and could verify its performance during cold climate condition. Now, these are some of our demonstration projects in North America. 1, Chicago. 2, California. 3, Maine. 4, 5, Boston. Let me explain the details one by one with the field data from the following slides. First, Maine, Newport. We installed high temperature Altherma in a single family new construction home. Their building is around 4,000 square feet, -5 degree design temperature, and the heating load is 45,000 BTU. They installed underfloor heating on the first floor and 2 convectors on the second floor for heating and cooling operation. As you can see from figure 2, the average heating COP during March 15th to 19th last year was 3.95 at 35 average ambient temperature. Also, we measured how long we need to wait until we have full hot water with 50-gallon tank. We filled up the tank with tap water, 62 degrees, and heated up the tank with heat pump operation only in July last year. It takes 60 minutes to heat up the tank with 120-degree hot water. Then, how about the COP and heat up time in winter? The average heating COP was 2.86 during January and February this year at 90.2 average ambient temperature. Also, when we check the heat output from the unit, around 85 to 9% of heating was produced by the heat pump and 10 to 15% by booster heater. This building is not fully insulated yet, so we expect the heating by booster heater will be lowered next winter. Domestic hot water performance in winter. We filled up the tank with tap water 52 degrees and heated up the 50-gallon tank with heat pump operation only in January this year. It takes 72 minutes to heat up the tank with 120-degree hot water at 14-degree ambient temperature. The average COP was 2.12 to heat up the 50-gallon tank from 52 to 125. We received some comments from the homeowner that Daikin Altherma is providing the majority of the home's heating needs and is very quiet, both indoors and outdoors. At the same time, we also found some key barriers and enabling factors. Air-to-water heat pump is new to many US contractors, so training will be key to making sure that proper hydronic designs and installation are achieved. Second, California Sebastopol. Their building is a single-family home with around 1,700 square feet. We replaced from their 100,000 BTU gas boiler and gas water heater to mid-temperature Altherma. Their first floor is underfloor heating, and we added one convector on their second floor. As you can see from figure 2 and figure 3, the average heating COP was around 2.5 to 5.0, and cooling COP was around 3.0 to 8.0. By changing gas boiler and gas water heater to Daikin Altherma, they could reduce their annual energy cost from $1,000 to around $600. We also received some feedback from the homeowner. They said that Daikin Altherma worked well, providing heating, hot water, and cooling. They also found the comfort level and noise level to be satisfactory, with the outdoor unit located just outside the living room window. At times, they noticed that the noise level was actually lower than it was before with the boiler at times. Third, Chicago lab. High temperature Altherma is being lab tested at a third-party research institute in Chicago with heating, cooling, and domestic hot water performance, COP, compared to those of boiler, furnace, and even cold climate heat pump. As you can see from figure 1, a comparison of heating COP at 45-degree ambient temperature shows that Altherma COP is 4.9, which is 63% higher in COP than cold climate heat pump. Also, Altherma COP is 2.1 even at minus 13-degree ambient temperature compared to that of cold climate heat pump, which is 1.6. CO2 emission and energy cost. Based on the third-party lab data, we found that Altherma represents 46% decrease of CO2 emission and 58% decrease of annual heating cost compared to gas furnace. We also have our own simulation data on energy cost and CO2 emissions compared to gas boiler and gas oil boiler in San Francisco, New York, Boston, Halifax, and Montreal from 1,500 square feet to 3,000 square feet. COP compared to other air-to-water heat pumps and cold climate pumps. We also have higher COP compared to other air-to-water heat pump and cold climate pump with 13-degree living water temperature. Altherma Advisory Committee activities. We introduced Daikin Altherma and explained our field and lab data to the utilities and standard organizations. We also discussed marketability, rebates, challenges, collaboration, support, and we will continue these activities. Let me skip the details. Fourth, Massachusetts, Layham. This project is based on the cooperation between utility, energy firm, contractor, and Daikin. We Daikin provide the Altherma units with technical support. An engineering firm will manage this project, measure and analyze data, and report it to utility and Daikin. A utility company provides project funds, including installation fee, and will make a pathway to give rebates or differentiated rebates on Daikin Altherma. We believe this kind of cooperation could be a good example of implementing and expanding Daikin Altherma in North America. This house is a 2,200 square feet home with 3 bedrooms and an unconditioned basement. The existing systems consist of a 153,000 BTU gas boiler and a multi-split heat pump with an air handler unit in the attic. We are replacing the gas boiler and multi-split heat pump with Altherma now. There are 2 goals for this project. One is to show that existing radiators can heat the home with Daikin high temperature Altherma. The second is to maximize the COP of the unit. Lastly, on this page, I'd like to add one more case study in UK, Europe. Home builders' choice of Daikin Altherma supports their smart home campaign. This home builder says that we expect Daikin to be open to feedback, to support the process, and to learn from each other. He also said that Daikin have supported us commercially, technically, and operationally, and in turn, we offer Daikin our commitment to specify their products. Daikin listened, and the relationship has developed into a true partnership. Daikin also supports our customers by offering home demonstrations and delivers more and more training to our installers. Our customers absolutely love the fact that we are an A-rated builder. Yes, we Daikin will listen to your voice and support you commercially, technically, and we will develop this relationship into a true partnership. We'll also support your customers by offering home demonstrations and deliver more and more training to your installers. Finally, we are happy to contribute to make your customers absolutely love the fact that you are an A-rated builder. Thank you.
Great. Thank you so much, Mr. Hong. Kelly, we have a million questions from the audience. Kelly,
Yeah.
you've been going through some of the questions I think it's almost easier if you want to highlight. So I know you've been typing some responses as we go, but
Mhm.
I wonder if you'd be interested in highlighting some things that you've seen in the questions, including, I think the most pertinent one I saw was what I will say is the four sizes of units that are going to be available initially.
Okay. Well, actually, it's two sizes that will,
There we go.
yeah, initially launch. Now, we have a portfolio or a roadmap, if you will, in water heating. It does include systems that don't necessarily operate at these high temperatures. We have a medium temp unit or system that we have in our roadmap. So those are other units and more sizes coming. We also expect to have smaller high temp sizes inside this system. What we find, especially with the high efficiency builders, and Aaron, you pointed this out
Mhm.
before when we talked about this system, we're dealing with homes that have very low loads,
That's right.
even in cold climates. And it's amazing that a home can have these low loads, but they're that way because the envelope is very well engineered.
Mhm.
And so we aim to have sizes that will accommodate even the smaller loads. But with outdoor reset and varying water temperature to get the efficiencies, there's a lot of customization that can be done with these systems. Yeah.
Understandable.
Aaron, I see a lot of questions about settings and
Mhm.
customization, things like that. What I want to emphasize with this system, and Mr. Hong always reminds me, if you can imagine a setting in a system, we got it.
Mhm.
Now that could be a little bit scary for some people, but the system is defaulted to protect the domestic hot water first and then serve the space heating and cooling effectively with high efficiencies. But all of these schedules can be altered. Um, the system can be customized. Again, the outdoor temperature reset can be modified and customized to give you higher COP. But out of the box, the system is set up very effectively,
Mhm.
to do all three modes.
Mhm.
So, yeah.
So I think the most of the audience, they are very curious about how we can make balance between domestic hot water and space heating or domestic water and space cooling. So
Mhm.
uh, I think our Altherma product specialist, Steve, might join this webinar. So Steve, if you join this webinar, can you explain how we can modulate the space heating, cooling, and domestic water?
Hold on, I might have to promote Steve to a
Oh,
Yeah,
okay,
Stephen McKinnon. Yeah.
okay. Then I will explain in advance. Okay.
is it MCK?
Uh,
There he is, Stephen McKinnon.
yeah, right.
Okay, hold on, Stephen. I'm trying to do this. There we
So,
go. So
mm,
I am going to make a presenter change. Stephen McKinnon, you should now be able to present
Hello,
to our
how are
screen.
we?
Yes, hi, Stephen.
Hello, everybody.
Hi.
Okay, so could you just repeat the question just to make sure I answer it correctly?
okay. So, Stephen, can you explain this very difficult graph with a simple
Yes, for sure.
explanation? Okay.
Absolutely. So I will do my
Love
best
it.
to explain this as simply as possible. So traditionally during, let's just say initial power up, you start up in space heating. There's a three-way diverter valve that will shift from space heating to domestic hot water depending demand. Domestic hot water does have priority, but as Kelly kind of explained, there's a lot of settings that can make it a little bit more flexible for you, so you can actually make space heating a priority. Whereas Mr. Hong kind of stated in one of the questions that space cooling cannot be set to a priority. It will still be a domestic hot water operation. Now, there's no simultaneous operation. So if you have a domestic hot water request, space heating will then operate for a limited amount of time before shifting over to domestic. And then after the domestic max run timer is engaged, which is also variable, it will then shift back to space heating, leaving a timer in place to go strictly domestic hot water, which is also variable. And then in turn, we'll kind of cycle back and forth between domestic and space heating or space cooling, depending on how you kind of set it up. And then kind of sliding down the chart here on the left, you can see booster heater, three-way valve, things like that. There's also electric strip heat, not only for the heat pump, which is backup heater, but the booster heater would also be for the domestic hot water. So those can also be staged and scheduled and timed in various ways, again, depending on your application. We are going to be implementing a lot of this information into our installation and commissioning training going out hopefully this fall. So it can kind of maybe explain it a little simpler than this slide, particularly because it's not a very intuitive slide. But yeah, that's kind of the general understanding on how it kind of operates.
Thank you.
So I think one of the things that we just want to make clear, and there were some questions during the presentation, whether this is a retrofit or new product. And having lived in New England, where I actually had a oil-fired boiler with no access to natural gas,
Wow.
this is the perfect product for a retrofit replacement for my house, my former house in Connecticut. And Kelly, I don't know if you just want to hit on that a little bit more, but obviously, I mean, I had baseboard water-fired heat, throughout that home, and had a window air conditioner. But I don't. You just want to reiterate that this is a great solution for
Yeah,
retrofit for the audience.
it certainly is. Like I said, I see the opportunity for replacement, but I also see the opportunity to design from the very get-go and put in that customization for, in-floor radiant heating.
Yeah.
It just once you've had that in a northern climate, you'll never go back. You always want that nice in-floor heating. But we've done the calculations on the return on investment. We've looked at it's so easy to navigate through the return on investment when a truck is backing up down the driveway with a lawn
Oh,
hose and glumping
Kelly, I
oil
used
into your basement.
Kelly, I used to have a nightmare every time I heard that guy backing down my driveway. It was like
That's
it was $1,000 in the
right.
wintertime.
And
Thousand
depending
bucks.
on how poorly insulated your home was, you might have to hit that like twice a year.
Oh, mine.
You know.
What's insulation? My house said. So,
But I think and so that's all to do. You also mentioned the window shaker. You could replace that easily here,
mhm,
where you've just got constant year-round, perfect cooling and in wherever space you want.
mhm,
Um, but then designing from scratch in the new build environment, the way I see these systems operating is they would give the consumers in a given heating dominated region the same comforts that you had previously with a boiler, but in a very modernized package. And I feel like the underfloor radiant heating combined with, let's say you don't even want to see the fan coils, just use the hydronic air handler.
right.
And you've got so many options on how
Mhm,
you customize a home. I
yeah.
think this is a really nice system to add that. And hey, by the way, depending on how nice of a home you want to go to or build, you can put another one in and do the driveway and
Mhm,
sidewalk mill. The
mhm,
system is highly flexible. And as
mhm.
Mr. Hung always says, if you can imagine it, this system will do it.
Oh, that's
You
great.
can, yeah.
Um, one of the questions I was really intrigued about was a tour of pilots, particularly from some guests from Boston. And then
Oh,
are there any installers in Boston? I of course said that we'd love to have you come visit us September 17th through 19th at the EBA Summit we will have a pilot installation that people can visit during the summit. But, Kelly, I don't want to put you on the spot, but it might be something to consider in that Boston market for some of the guests.
Yeah, I think what we can do is gain permission, provided we gain permission from the building owner or the homeowner. We could do some spot tours, select tours where people can come and understand the application and see it in real life. That's the whole idea behind a field trial anyway, right?
Yeah.
And National Grid and also
Eversource.
Eversource are
Yeah.
there. We're working with them in tandem because they see the value in these systems and they want to incentivize them.
Yeah, that's
So
great.
these
And then,
homes are very well done.
Kelly, I assume you have some installers that have put this in. My intuition is that really, um, obviously a heating professional can put this product in, a plumbing professional can put
Right.
this in, but any market where you have a strong hydronics installer base, like they're going to get this from the word go.
Yeah, I think the sizing, there is a little bit of nuance to the sizing instead of using boiler sizing practices. But again, BTUs are BTUs, and once you look
That's right.
at room by room, you can get this size properly. The next question is, how fancy do you want to go with hydronic separators and zone pumps and zone valves? That philosophy varies region by region, but the system delivers a predictable amount of hot water or chilled water at a given flow rate. And from there, the design practice can be picked up by anyone that understands hydronics.
Fantastic.
Yeah.
Mr. Hong, any final thoughts as you reviewed the questions for our audience today?
So first of all, I'm very happy that so many technical questions are there. So
there was a lot of good ones.
yes,
Yeah.
actually, this technology is very new in North America, and even with Daikin, we do not have 100% confidence in North America. That's why we have a lot of demonstration projects. But yes, we would like to answer one by one after this webinar, if we have a chance.
One thing that I considered is, we get a readout of all the chat and all the Q&A, and that we may want to take that offline, do an FAQ, response, and then we can send that to our audience members, or we can go through it in the next webinar podcast series.
Great idea.
So,
good idea.
yeah,
Thank you.
I don't want to,
Thank
make you do
and
that,
then,
but I think it's a
Aaron,
logical
I think that's
way.
why you're the CEO and president.
Yeah, and especially what we are interested is that some member question is cost. Yes, cost is very important. That's why we promote the rebates on this new system, and at the same time, the big impact will be on the big factor will be on installation cost. Installation cost means where you install outdoor unit, where do you install indoor unit, and tank and emitters. It's more than 70% of total cost, we believe, or even 8%. It depends on the application. So let's develop application by application how we could provide affordable price to our homeowners.
Yeah.
I got a couple of comments there real quick before we part, but on especially new construction, what I really appreciate about a system like this, and we have other products in our portfolio I mentioned that we're working on, maybe just strictly heat pump water heaters for southern built districts, but these tanks can be placed anywhere. And they don't have any space constraints like traditional or the current heat pump water heaters where they're integrated with a heat pump module over a tank. I love the idea that they've fashioned those to be basement dehumidifiers. that's great, but they still have a space constraint.
That's
Whereas
right.
in this system, if you want to put the tank under the staircase,
Yeah.
as you may have previously in your builds, or you want to put it in the the garage or the attic or the basement, your placement is any placement is good.
Yeah.
Yeah.
And no work, I mean, zero noise coming from that tank,
No, no, that's right. And
which is
I
really,
think the other thing I was going to point out is in terms of, we're not publishing our list price today in this webinar, but
Mhm.
I want people to imagine that if you were to add the requirements or the cost of space heating, space
Mhm.
cooling, and domestic hot water, our efforts and uh, our philosophy from senior management is that we're going to be competitive. We might be a slight bit more premium because there's a few more pieces to put together, but we'll be competitive against those three systems added up. And I think that's where you
Right.
need to be in the market.
That's right. Well, that's great. Kelly, you had mentioned contact information. Do you want to provide that to folks that want to reach out to you? Or we can follow up via
I
email
think we can
too,
send
Jerry.
that back out.
Okay,
I didn't have that on the slide.
that's okay.
Yeah,
Well,
but
people can reach out to me, also Aaron at eba.org, and I'm happy to make connections as is appropriate. Well, I want to thank you both so very much. I want to thank you for so many people that attended today. This will be available on the eba.org learning management system and then on our Better Homes, Better Future podcast. I think we'll be able to see, excited to see a unit in the wild coming up in September in St. Paul. So that'll be exciting. But again, Mr. Hernsberger and Mr. Honk, thank you so much for joining us today. And probably the first of many of these presentations as we all learn about this great new technology.
thank you for the
Great.
time.
All right. Thanks, everyone. Take care.